I've had the opportunity now to do 2 state penitentiaries, and it's a very unique environment for Wi-Fi. So it's kind of overview of the site of one of the sites that I did. It's an interesting environment because there's a lot of trade-offs. So I think a lot of times we talk up here, we talk about sort of best case scenarios, right? And we talk about sort of optimal Wi-Fi. There's a lot of trade-offs that you have to make in order to work in one of these environments. If anyone's done like a psych ward in a healthcare environment, it's very similar, except the entire place is like that. So talk about Wi-Fi use cases. This is a massive hospital for the prisoners within the state of California. Some of the primary use cases were telemedicine and telepsych. So allow the prison guards to bring doctors to the patients via video conferencing, right? It allows the doctors to safely see as many patients as possible and minimize security clearances and all those interesting challenges. Also, mobile X-ray and ultrasound, same sort of concept. Productivity and safety, so productivity for the employees of the prison, safety as well. Can't have, Cat 5 laying around. No guest Wi-Fi. Sorry, Keith. Definitely not free in there. And the just low bandwidth requirements in general, right? So it is video, but it's generally one device, right? There's not a lot of wireless being used in there. So some of the challenges we ran into, first of all, customer expectations. In a facility that is all poured concrete, when we first talked to them, they said, we want neg 50 everywhere. It's not going to happen. Tools management. So one of the interesting things about working in a prison is at any time someone can come up to you and ask you where all your tools are. You better know. So we had to kind of document everything, carry it with you, take as little as possible in. So that was kind of interesting. Omnis only. I had a hard time with this one at first, given what we were trying to accomplish. Kind of when we looked at the predictive plans, we were like, all right, we'll use some directionals, those kind of things. They only want Omnis. They can't have any liability of having these other antennas in use. Construction challenges like crazy, right? So poured concrete construction, steel rebar everywhere. Restrictions in access point locations, so everything had to be 12 feet above the ground or in all sorts of crazy enclosures if below that. And then accepting all the trade-offs, right? So co-channel nightmares, you guys will see in a second. So brand new construction, so predictive design was absolutely a necessity. And as part of this, they were actually manufacturing a lot of the stuff off-site. One, for union issues, 2, just access issues to the site. So they really kind of built a lot of stuff, and then they brought it on and put it together sort of like Legos. And that included where all the conduits had to go for the access points. So they wanted to know in advance where those access points were going to go so they could prefab everything off-site and then build the Lego blocks on-site and have the Wi-Fi work perfectly. And going back to fix anything was very, very difficult. So we kind of went through this. There'll be a cleaner shot of some of the floor plans here in a second. And what you see, you'll have these areas where it's wide open and an AP will just carry, right? So as you can see here, there's a lot of co-channel, or potential for co-channel anyway. And so we try to be strategic about where we place things, but again, it's never going to be perfect in this type of environment. So you can kind of see there's three main zones. This is what one of the places that were considered dorms, right, or one of the major cell blocks, if you will. There were 6 sort of zones of cells, so you can kind of see north, south, and then either east or west, depending on the side. And then all the central core were all essential services. So it's construction similar to a hospital, other than everything's concrete. In case you've never been inside one, hopefully most of you haven't. Kind of a cool view of what one of the end rooms looked like, right? So big open room on the little guard tower up top, a big day room down low. All the cells there's a small catwalk, and cells were kind of upstairs and downstairs. I called out one of the access points. You can see it on the kind of on the wall. It was, not ideal orientation, but it's set up there so it could actually shoot out towards the rooms and help with coverage, because doing like right angle brackets or any of those things we were not allowed to do. And then a sample of one of the cells. And there was actually no requirements to carry Wi-Fi into the cells. It was just to the front of the cells where they'd bring like a portable X-ray machine or something along those lines. So you can kind of see, I kind of drew some of the placements over, kind of mapped them so you guys could see it. And then obviously, just like any other deployment, going through and doing validation surveys are important, right? Did we hit the mark? And one of the things that everyone kind of accepted as we go into this, it's not going to be perfect, right? Just too many restrictions on where we could place access points. So you can see sort of in that top left area, there's a place where we didn't quite hit the marks. Everybody was okay with that.
Did you have a percentage of error from a perfection, or was it just a nebulous, maybe not?
Yeah, it was more of a judgment call, right? So it's like in here, one of the specific challenges about this one, so you can see just to the left of that, there was a wall, right? So on the end cap sort of rooms, we could have an AP that would be wall mounted and sort of shoot, would be a little to the left on the diagram, right? But there's no way to get any kind of back lobe or anything to pick that up. So it's just sort of like, hey, this is where we're at, good enough, right, sort of thing, right? So they're like, yeah, that's fine. We can live with that. But it was really hard to deal with those trade-offs at first. We always strive to have Wi-Fi as perfect as we can, and going through that was kind of a personal battle. So anyways, just I don't know if there's any other questions. I just thought it'd be kind of interesting view for people who might not have been able to see that before.
So what RSSI were you able to actually achieve for the cells?
We had to hit neg 65, and so it was really neg 65 to the outer door of the cell, and we were able to hit that pretty consistently, and that was more of a requirement for some of the medical devices, and to get a combination of quality signal and a decent data rate to that device to transmit.
What was the use case? Was it for the population, or was it internal use, or both?
It was just for the more for the medical, and then also there's some communication stuff that some of the guards would carry. They don't allow. There's no cell phones, nothing like that's allowed. I had to get clearance just to take some of the pictures because I use my cell phone for it, but they don't allow that stuff in there typically.
Were they looking at tracking the prisoners with RSSI?
So they do, but it's another system.
Was it a typing system?
It's a different frequency, so you can see that little, just to the left of the AP, there's sort of that one that slants out an angle. That was a tracking system, but it's a whole prison-specific tracking system. I didn't have to deal with it.
What did you use? Just out of curiosity, what vendor?
All the APs were Cisco. It was just the standard for the state. What's that? The goal was to get it on 5 gigahertz. 2.4 is a mess in there, really as spaced out as it was, we had to leave all the 2.4 radios on. Code channel is awful. Say it again, sorry. No real sources of RF interference. The place is in the middle of nowhere, so so anything that's there is part of the system. All right.
All right, thank you.
Thank you very much.